So when we're dividing square roots, there's a couple things we have to keep in mind. First of all is that rule, the number one rule about dividing with square roots is you're not allowed to have a square root in the denominator. You're not allowed to have a square root in the bottom. All right, so basically whenever we have a problem like this, a fraction, it is a division problem because fraction means division, and we need to make sure we simplify it all the way, and we need to make sure that we don't have any square roots in the denominator. If we've done those two things, then that's all we can do. All right, so in the first one, if I need to get rid of the square root in the denominator here, well, let me ask this first. Sorry, I'm skipping ahead. Can I simplify coefficients in this problem? No. So we have a 2 in the coefficient here. We have a 1 in the coefficient here. We can't simplify those, so there's nothing to do with simplifying coefficients. Can I simplify the radicands? No. So I have a radicand and a radicand here, but I can't simplify them because there's nothing that goes into 3 that also goes into 5, right? Okay, so that's the first thing you want to check is to see if you can simplify the coefficients or see if you can simplify radicands. Once you've done that, then we're going to try to get rid of the square root that's in the denominator. So to do that, that's the step where we're going to multiply by a square root over a square root. And what do I put in the square root here? The 5, the one that's in the bottom, right? So since we're trying to get rid of the square root in the denominator here, that's the square root we want to multiply by. So we're going to multiply by the square root of 5 over the square root of 5. All right, so when we simplify that, on top, our coefficient, we only have one coefficient, we just have that 2, so what do we get on the outside? 2. And what do we get on the inside? 15. So we multiply the inside number times the inside number to get the inside number, 15. All right, and then on the bottom, what's the square root of 5 times the square root of 5? 5. All right, that's the whole reason that we did this. We wanted to get rid of the square root, so we multiplied by something that's going to get rid of the square root. So the square root of 5 times the square root of 5 is 5, and that's it. That's all we can do, right? So there is your answer. Now, we do want to make sure that we simplify everything we can. Why can I not simplify, let's start with the coefficients. Why can I not simplify the 2 with the 5?
Because 2 does not divide by 5.
Yeah, there's nothing that goes into 2 that also goes into 5, so we can't reduce that. Why can I not reduce the 15 with the 5?
Because the 15 is in the square root and the 5 is in the outside of the square root.
Good, so 15 is inside the square root, 5 is outside the square root. You can never simplify an inside with an outside. All right, if you wanted to do that, you would have to try to factor this and make pairs and pull them out and then simplify it. But if we've done it correctly, we won't have any pairs. Would we have any pairs here with the square root of 15? No. If we factor it, it would be 3 times 5, right? So there's no pairs of numbers, and we won't be able to simplify that. On the second problem here, what can we do before we start trying to get rid of this square root? There's something that will reduce before we can get rid of the square root. Can I simplify the 24 with the 2? Can I simplify the 24 with the 3? Yes. All right, make sure you don't simplify it with the 2 because the 2 is inside the square root and the 24 is outside the square root. So when we reduce the 24 with the 3, what goes into 24 that also goes into 3? 8 goes into 3? What goes into 24 that also goes into 3? There's not many options. There's only 2 things that go into 3. One's not a good choice because it doesn't do anything. The other one is 3, right? So we divide by 3, and what's 24 divided by 3? 8. And 3 divided by 3? 1, right? So if we want, we can leave that 1 off because it's our coefficient. And if you have a coefficient of 1, you don't need it, right? Okay, so we can put a 1 there, but we don't really need that. Can I reduce the 8 with the 2? No. Be careful that you don't do that. That's an outside number, that's an inside number. So you can't reduce those. So the next thing we need to do is get rid of that square root. To get rid of the square root, this is the step where we multiply by a square root over a square root. And what is the square root we're going to multiply by? 2. So on top, we're going to get, let's see, we had an 8 there, and we're going to multiply by the square root of 2, so we get what? It's almost too easy for those. When you have an outside number times an inside number, you just keep it just like that. So we get 8 square root of 2. On the bottom, we have square root of 2 times the square root of 2, which is 2. And now that we've gotten rid of the square root, we're done, right?
No.
Why not? What can we do here?
Yeah, divide by 8 by 2.
Yeah, we can reduce the outside numbers here, right? What goes into 8 that also goes into 2?
4.
4 does not go into 2, guys. What goes into 8 that also goes into 2? 2, right? Now, this one actually, we don't have to reduce, but we could just divide, couldn't we? Can we do 8 divided by 2? Yeah. So let's do it that way. Let's do 8 divided by 2 and get 4. So we'll rewrite our answer. We don't want to leave it like that. That's kind of sloppy. So we get 4 on the outside, 2 on the inside. And since we don't have anything left in the denominator, we'll just leave the denominator off. On this next one, it's probably really tempting to start off the problem by doing this. And this would not be a good thing to do. You could get the right answer if you do this. But what's wrong with multiplying by the square root of 3 over the square root of 3 to start off with here? Yeah, it can simplify first, right? So if we did this, you would get the right answer if you simplify everything in the end, but it's going to be a lot more work. All right? So what we would end up with is a square root of 18 on top. And the square root of 18, we would have to factor and circle pairs and pull those pairs out. All right? But to avoid doing that, instead of multiplying by the square root of 3 over the square root of 3, we can start by reducing. What goes into 6 that also goes into 3? 3, right? So if we reduce by 3, what do we get on top? 2. And what do we get on the bottom? 3 divided by 3 is 1, right? So if we get a 1, what can we do with it? So we can just leave that square root off completely because it's going to be the square root of 1, which is 1, and 2 times 1 is 1. So this really just goes away. That 3 cancels out completely. So what we end up with then on top is what? What do we have on top? It's not 2. It's the square root of 2. Okay, it's important that we remember that that's on the inside. And then on the bottom, what do we have? 2. Can I simplify that? Can I cancel those 2's out? Why not?
One's on the outside, one's on the inside.
One's on the outside, one's on the inside. So we can't simplify that. There's nothing we can do to cancel anything. We can't pull any pairs out of the square root. So we are done. Okay? So actually in this problem, we didn't have to multiply by the square root over the square root because by the time we simplified, the square root in the bottom was gone. For this last one here, the first thing we did with a problem like this is we rewrote it. You guys remember that from yesterday? So instead of all of that being under one big square root, we're going to give each of them their own square root. So we have the square root of 1 over the square root of 20. Now on top, what is the square root of 1? It's just 1, right? And on the bottom, the square root of 20, we can simplify that. So what I'm going to do is I'm going to go off to the side and I'm going to factor it and see if we end up with any pairs. So we have 2 times 10 and 2 times 5. So when we rewrite it, we get the square root of 2 times 2 times 5. And so when we circle our pairs, what are we going to end up with? 2 on the outside and then 5 on the inside, right? Okay, so we get 2 square root of 5. So what we're going to do is we're going to take this and replace the square root of 20 that we had in the bottom here. So this is going to be 2 square root of 5 here. And are we done? No. How do we know that we're not done? We have a square root in the bottom, exactly. So since we have a square root in the bottom, we have to get rid of that. So this is, again, the step where we multiply by a square root over a square root. And what square root are we going to multiply by? 5, right? So we need to get rid of the square root in the bottom, We need to get rid of that square root of 5, so we multiply by the square root of 5 over the square root of 5. And on top, this should be pretty easy. What do we get when we do 1 times the square root of 5? Just 5? Square root of 5, right? So this is, if we do 1 times anything, we get the same thing. So 1 times the square root of 5 is the square root of 5. 1 times 17 would be 17. 1 times the square root of 7 would be the square root of 7. On the bottom, this is a little bit trickier. What is the square root of 5 times the square root of 5? You guys told me up here, square root of 5 times the square root of 5 was 5. So down here, the square root of 5 times the square root of 5 is 5. But then we also have to multiply that by 2 and get 10. Okay, can I simplify that? No. So we do have a 5 and a 10 here that look like they might simplify, but again, the 5's on the inside, the 10's on the outside, so we cannot simplify that. So this right here is as simplified as it will get.